Hello everyone, I am again with you with my next video lecture, and in this video lecture we will study the concept of representation of force under the heading statics. So this is my second video lecture on the book of statics of BSc third semester. So now we will study the concept of representation of a force. Representation of force. So force is represented by a straight line. You will say, how will it represent the straight line? Like, let us say this is a straight line starting from A to B. So this length of the straight line represent the magnitude of the force. So this is the magnitude, and this arrow sign represents the direction of the force, and the initial point, the starting point, this represents the direction of force from A to B, and AB, that is length of the straight line is magnitude, and A point, the initial point, is point of application. So if we say this is one line and this is the, let me have a straight line, straight in the sense that it is this is the straight line, and say this point is A, this point is B. So obviously if we see, say if this force is represented by F and this force is represented by G, then clearly G is greater than F in magnitude, and in direction, if I say this is in this direction, both are parallel, F is parallel to G, and point of application is the, say it is represented by A1, say it is represented by A1, say it is B1. So A1 is point of application of this force G, and A is point of application of this force F. So that is the notion that you use to represent the force, and it is very easy. So initial point is the point of application of the force. If I say this force is applying at A1, and A1 B1 is the magnitude and A1 to B1 is its direction, and clearly since it is greater in length, this is smaller one than this one, so this G force is greater than F, and since both have the same direction, then both are parallel to each other. So this is the representation of force, and if we want to represent it in the vector notation, that we can say that AB and vector over it representing the force from A to, this is representing the force from A to B, and this vector denotes the direction from A to B. So we can write it as a force, and if I write here as force, and in the subscript we write AB, means force F from A to B. And similarly, if we write G from, what you will say, A1 to B1, so here is the vector. So you could also write it something like that, F like G vector from A1 B1. This is more standard that we will be writing in this one. So this will be F and AB. So this is the standard notation. This is representing the force F from A to B and acting at force F from A to B acting at A, G from A1 to B1 and acting at A1. So this is the representation of force, and these are the notations that we have used. So now next we will be moving about the second topic, moving to the second topic, and the second topic is equilibrium of forces. Equilibrium of forces. So for if we say that when forces are in equilibrium, equilibrium of forces. When two forces, say we have two forces, when are they in equilibrium? Like this is the body acting. For forces to be in equilibrium, they have to be in the same line. So if I apply a force, like this is the force, and we continue it in the same direction, and this is the second force, this is in this direction, this is in this direction, and both have to be of same length, like that. So then I say that this is F2 force, this is F1 force, both are in equilibrium. Because if we see here, this is in this direction, this is in opposite. So forces to be in equilibrium, they have to be in opposite direction. So I am going to write the first condition, that they have to be in opposite direction. Number 2, they have to be equal in magnitude. Look over here, the length has to be same. Length has to be same. So if I write the second property, that they have to be equal in magnitude, they have equal, magnitude is equal, direction is opposite magnitude. And number 3, they are present in the same line of action. They are present in the same line of action. So that is number 3 property. Like here you see the line of action is same. So they have the same line of action. They have same line of action. So these are the 3 conditions that we require for two forces to be in equilibrium. Similarly, other two forces could be in equilibrium. If I say, if I draw a straight line, so that will be more suitable. Let us say I draw a straight line from here to here. Fine, this is the straight line, and I say the line of action is this one. Okay. So if I say, and if I name the points, say this point is A1, and say this point is A2, this point is A2, this point, and this point, and this point is B1, and of the same size, this point is B2, and if force is acting in this direction, another in the opposite. So these two forces, and if I say this is F3 and this is F4, so I say F4 which is in the direction. If I write in the subscript notation, F4 is in the direction, you will see it is from B to A2. So if I had to write, I have to write B to A2, and F3 is, you will see it is from B1 to A1. So I have to write B1 to A1, B1 to A1. This is A1. Fine. So this is the force F3, this is the force F4, and these forces are acting in the opposite direction and their line of action is same. So I can say that both the forces are in equilibrium. Both the forces are in equilibrium. If I say both forces are in equilibrium. Similarly, F1 and F2 are in equilibrium. If I say that, similarly write F1 and line of action, if I write it down, I could say that this point, what should I be naming it as? Say this is P1, this is Q1, this is, if I say this is P2, this is Q2. So F1 is from, you will see, from Q1 to P1. This shows the direction. Q1 to P1. Q1 to P1. And F2 is from Q to P2. So these both forces are also in equilibrium. So this is the concept of equilibrium. So principle, the main behind this is that these three conditions have to be satisfied if the forces are to be in equilibrium, if the two forces are to be in equilibrium. And if a body is under equilibrium, then it will be under the influence of even number of forces, and these forces would be countering each other in pairs of 2. So that is the equilibrium of the forces, any number of even number of forces. Okay, fine. So that will form the equilibrium. Now we will study the Newton's laws of motion. So I am going to study Newton's laws of motion. These are very important laws as far as statics, dynamics is concerned, or if I say that collectively as far as mechanics is concerned, these laws are very important. What is first law? If I say that first law is also known as law of inertia. In Hindi it's called Jadatva. The law of inertia states that it is the inability of a body to change its position itself. What does it mean? If a body is in rest, say this is in rest, so itself, without the application of the external forces, this body, if it is at rest, if I say this body is at rest, it will continue to be at rest, without application of some external agency. Agency can be in form of force also, or some effort. So this will continue to be. So this is what we call as Jadatva, Jad, that is not going to change. until and unless some external agency is applied upon it, it will continue to be in the position of rest. It will continue to be in position of rest. And another version, if we could see that this is a body, and say if it is in motion, it is moving, say after that some time it is over here, it is in motion. So this law states that it continues to be in motion, it will not stop, it continue to be in motion. Motion means it will not change its position of motion, it continues to be in uniform motion unless some external agency is applied upon it. So this is the second notion, this is the second notion, this is notion number 2, this is the notion number 1 of inertia. So if I say it is the inability of the body, first law states that it is the inability of the body, inability of the body to change, inability of the body to change the state, to change the state of motion itself. State of motion or state of rest itself. It cannot change. If it is at rest, it will continue to be at rest. If it is in motion, it continues to be in motion. It is the inability of the body to change its, you could write over here, change its state of motion or rest itself. So that is very simple, and this is also known as law of inertia. Law of inertia, this is Newton's first law, and I think you would be able to grasp the idea. It is very important law. Now we will move towards the second law. What is the second law? Now second law of motion, and of course it is Newton's law. It states that the rate of change of the linear momentum with respect to time is directly proportional to force applied, and this change takes place in the direction of applied force. So this is the second law. If I write it down, the time rate of change of linear momentum is directly proportional to force applied, and this change takes place in the direction of applied force. So without this it will not be vector quantity. So you have to mention this, that this change is taking place in the direction of applied force. Only then, because force is a vector quantity, and you have to mention both. The magnitude is equal to You have mentioned the rate of change of the linear momentum, and what is the direction of that change is the applied force. So the magnitude of the force will be the rate of the change of the linear momentum. So you have to write the applied force, it is very must condition. So this is the second law of the motion. Like if a body is moving with momentum, say here is a body, if I say here is a body, say this is the body, and it is moving with momentum p1 at time t1, and after some time, say this come over here, their momentum is p2, time is t2. So the rate of the change of the linear momentum will be proportional to the applied force. So say the applied force, whatever the force we have applied, say this is applied force, and this will be equal to p2 minus p1 with respect to time. So this is the second law of motion. So now we move towards the very famous law, the third law of the motion. This is very famous and you all know about it. This is the third law of motion. What does that law state? That it states that to each and every action there is equal but opposite reaction. Like we have this ground, we have, and if I say this is the ground, okay, and we have a foot, say this is the foot. I am not good at drawing, but I will still try. So it is pressing this ground with force F, and equal reaction is offered by the ground, that is also F in this direction. So say this is the force that is offered by the ground, and if I resolve, say this is the force, okay, force of reaction offered by the ground, and if say this is making angle theta, and if I resolve it into component, this component will be F cos theta and this component will be F sin theta. So if I make it over here, this is theta, this component is F cos theta, this component is F sin theta, and this component is nothing but equal to the weight mg of the body acting downward. So this vertical component helps in balancing the person. This helps in balancing the person, and this component F cos theta, this component helps in moving forward. Okay, so once again this is the second law, which states that to each and every action, to each and every action there is equal but opposite reaction. Fine. So this is the third law of the motion, which is of course Newton's third law. So these are the three important laws, and you students should take care that you should grasp the idea of all these three laws, because into your anywhere in your life you could be generally asked that what are the three laws of the motion, Newton's laws of the motion. Please give your opinion about them, what notion do you have about them, so please share with us. So these laws are very important, you should have an idea about it. So next we will be moving towards the Hooke's law, that we will be doing in the next lecture. So before concluding the lecture, I am going to recapitulate whatever we have studied so far. So in today's lecture, we have studied that how do we represent the force. Force is represented by straight line, its length represents the magnitude, its direction represents the direction of the force, and the point is the point of application. Further, as we will move in our course, we will study that point of application of the force can easily be transferred within the body to any point in the same line of action, and if that point is present, has to be present in the body as such. So that principle is called, we will study it later, principle of transmissibility of forces. So with this principle, the point of application of the force becomes irrelevant. It could be transferred to any point through its line of action as far as that point is within the given body. So that is the principle of transmissibility of the forces. So that we have studied the representation of the forces. Next we studied the concept of the equilibrium of two forces. So we have studied it through the examples. Next we studied the Newton's laws of motion. The first law, the law of inertia, also known as jadatva, the inability of the body to change its state of motion or rest itself. If it is at rest, will continue to be at rest. If it is in motion, it will continue to be in motion. So if it is in motion, it will continue to be in motion. Fine. So this is also known as inertia. Next we studied second law of motion, which states that the time rate of change of linear momentum is directly proportional to force applied, and this change takes place in the direction of applied force. So the rate of the change momentum, if say this is having momentum p1 at time t1, p2 at time t2, they both are different, then this is the relation. Next is the third law of motion. It said that to each and every action there is equal but opposite reaction. So we studied also another example. So after that, this is it that we have. So in the next lecture, this is all I have from this lecture. In the next lecture, we will try to take up the concept of transmissibility of the forces. We will try to take up the concept of gravitational unit of forces. We will try to do the to have an understanding of the Hooke's law. So these three concepts we will thoroughly study in the next video lecture, and that will be our third lecture on the static. And along with that, I would also take up the concept of tension and thrust. What is tension and what is thrust? So these four concepts will be thoroughly discussed in the next video lecture, which will be third in the series of the static. So I would expect you, and I would request all my students to bear with me through all these lecture series that I will be making on statics, because I will be covering the syllabus thoroughly, and I can assure you, I can guarantee that you will be able to understand the idea, you will be able to understand the concept. So please bear with me through the whole of the lecture series, and it is also a responsibility, once teacher has covered a 30 minutes lecture, it is your responsibility to go through that lecture on the daily basis, cover your syllabus, cover the numericals based upon them. And if you have any problem, you can drop it in the comment section. You could drop me a WhatsApp message. I would definitely reply, but responsibility upon your shoulders is very, very heavy, that you have to respond to the teacher with the equal momentum that he is doing it. So I expect you all to do good, and your progress will be monitored continuously, and I expect you to go through the lecture daily basis, because these are the signs of a good student. He never relax and just keep working. So this is all I have from this lecture, and in the next video lecture we will taking up the concept that we have discussed just now, at the 4 concepts. So if you have liked the lecture, please like, subscribe, share, comment. This is Dr. Rajesh saying you goodbye, take care, bye bye, and keep studying. Thank you very much.